Welcome to Cosmic Compass, where together we journey through the mysteries of the universe, from the planets and stars that light our skies to the vast forces shaping galaxies. This channel is your guide to exploring the cosmos. On a clear day, when we glance at the sun, it's easy to forget what we're truly looking at. To our eyes, it's just a bright disk in the sky, warming our world. But in reality, it is a raging sphere of nuclear fire, powerful enough to shape everything about life on Earth. Without it, nothing we know could exist, yet for all its importance and its constant presence above us, there is still so much we don't fully understand. This is why, in recent years, humanity has taken bold steps to get closer than ever before. Two spacecraft, NASA's Parker Solar Probe and ESA's Solar Orbiter, are venturing into dangerous territory, pushing their limits to explore the sun's mysteries. Why are we sending them so close? What exactly are they doing there? And perhaps the most fascinating question, what have they already discovered? Today, let's journey together through these daring missions. We'll see how Parker and Solar Orbiter are helping us uncover secrets of the sun, why this matters to us here on Earth, and what it means for the future of our delicate civilization. In 2018, NASA launched the Parker Solar Probe, the first spacecraft designed to dive straight into the sun's outer atmosphere. 2 years later, in 2020, ESA followed with the Solar Orbiter, a mission designed to observe the sun from a different perspective. At first glance, the goals of these missions may sound similar. Both aim to study the sun's atmosphere, its powerful solar winds, its unpredictable eruptions, and the complex magnetic fields that govern its behavior. But the way each spacecraft approaches the sun is unique, and together they complement one another like two halves of the same story. We're not just exploring out of curiosity. The sun isn't a distant object. It's the system that powers Earth, and sometimes it threatens us. By understanding how it works, we are ultimately protecting ourselves. The Parker Solar Probe was first announced back in 2009, and after nearly a decade of preparation, it launched on August 12, 2018, riding aboard a Delta Heavy rocket, its mission to get closer to the sun than any human-made object before. To achieve this, Parker uses repeated gravity assist 7 flybys of Venus over nearly 7 years. Each swing past Venus slows the probe just enough to shrink its orbit, pulling it closer and closer to the sun. At its closest approach, Parker will pass within just 6 to 16 million kilometers of the sun's surface. That is well inside the corona, the sun's outer atmosphere. Now imagine this being that close would feel like standing under 500 suns blazing down at once. Temperatures in that region can soar up to sun 400 degrees Celsius, or about 2,500 Celsius. At such heat, the materials that normally protect spacecraft would simply melt. So how does Parker survive? The answer lies in its shield, an 11 centimeter thick carbon composite wall coated with a white reflective layer. This shield always faces the sun, deflecting most of the heat and allowing the instruments hidden behind it to stay safe. Because Parker spends so much of its time behind its shield, it cannot always turn to face Earth and send data home. For long stretches of its orbit, it's completely cut off. That's why the spacecraft was built to be more autonomous than almost any mission before. It manages its own sensors, stores data on board, and waits until the right moment to reconnect with us across the void. The Parker Solar Probe is small, light, and stripped down compared to most deep space missions. But its simplicity is its strength. By daring to dive directly into the sun's atmosphere, Parker is giving us measurements we could never take from a distance. While Parker plunges into the corona, ESA's Solar Orbiter takes a different approach. Development began in 2012, and after 8 years of work, it launched on February 10, 2020, riding an Atlas V rocket. The Solar Orbiter also relies on gravity assist using Venus and Earth to shape its path, but instead of diving deep, it settles into a more stable orbit, circling the Sun every 180 days. At its closest, the spacecraft comes within about 43 million kilometres of the Sun, still much farther than Parker but far closer than Earth. Even at that distance, the conditions are brutal. Sunlight there is about 15 times more intense than on Earth, and the heat can reach 500 degrees Celsius or 900 degrees. To withstand this, Solar Orbiter carries a titanium foil heat shield layered up to 40 centimetres thick. Not as extreme as Parker's protection, but still enough to keep the instruments safe. Why not send Solar Orbiter closer? The answer lies in physics. Getting into a tight orbit around the Sun is surprisingly hard. Because Earth is already moving at nearly 30 kilometres per second around the Sun, any spacecraft we launch has to cancel out that sideways speed. In fact, it takes 55 times more energy to go to the Sun than it does to reach Mars. That's why both Parker and Solar Orbiter required two of the most powerful rockets available at the time. Solar Orbiter may not fly as close, but it carries a suite of powerful telescopes and instruments, giving it a unique role. Where Parker can touch the Coronal, Solar Orbiter can actually see it. So what exactly are Parker and Solar Orbiter trying to understand? At the heart of their missions lies the Sun's corona, the ghostly, wispy outer atmosphere that stretches millions of kilometres into space. You may have seen it during a solar eclipse, when the moon hides the bright surface of the Sun and reveals the delicate arms of plasma reaching outward. Here's the mystery: the corona is far hotter than the Sun's surface. While the photosphere, the visible surface, sits at about 500 degrees Celsius, the corona burns at 1 to 3 million degrees Celsius. Why this is so remains one of the great puzzles in solar physics. The corona also fuels the solar wind, a constant stream of charged particles flowing outward from the Sun in every direction. On Earth, we are shielded by our planet's magnetic field, which diverts most of the wind away. Yet some particles spiral toward the poles, colliding with our atmosphere and painting the sky with the dancing colours of the aurora. But the Sun isn't always steady. Sometimes its magnetic fields snap and reconnect in violent bursts of energy. When that happens, massive eruptions known as coronal mass ejections, CMEs, hurl billions of tons of plasma into space at astonishing speeds. If one of these eruptions slams into Earth, the results can be dramatic. The largest known event, the Carrington event of 1859, lit up the skies with auroras seen as far south as the Caribbean. Telegraph systems sparked and failed. If the same thing happened today, it could cripple satellites' power grids and communication systems. Some estimates suggest the damage could reach trillions of dollars. And CMEs travel fast. Some have reached Earth in as little as 17 hours. That's barely enough time to warn the public, shut down power plants, or move satellites into safe mode. In July 2012, Earth narrowly missed a Carrington-sized storm by just 9 days. Had the timing been different, modern civilization might have faced its first global space weather disaster. This is why studying the corona matters. By understanding how solar winds form, how CMEs erupt, and how magnetic fields behave, we can learn to predict solar storms, and prediction for us could mean the difference between inconvenience and catastrophe. Although Parker and Solar Orbiter share a mission, their approaches make them very different. Parker is the daredevil plunging into the corona itself, but this closeness comes with trade-offs. The spacecraft cannot carry fragile instruments like cameras. No current camera could survive staring directly at the Sun from such a distance. Instead, Parker samples the environment, measuring particles fields and plasma flows as they whip past. Solar Orbiter, by contrast, is more like an observer with a camera in hand. It carries both detectors and telescopes. From its safer distance, it can take close-up pictures of the Sun's surface, an atmosphere capturing details we have never seen before. Even more importantly, its orbit allows it to track the same region of the Sun for several days, something impossible to do from Earth. That means it can watch as storms build, grow, and eventually erupt. Together, the two missions form a perfect pair. Parker gives us direct contact with the Sun's atmosphere, while Solar Orbiter gives us the context, the pictures, and long-term observations to interpret what Parker feels. It's as if Parker is our scout on the front lines, while Solar Orbiter is the chronicler watching and recording from a safer distance. Both missions are still young, but already they've delivered groundbreaking results. In September 2020, Parker made history by coming within just 13.5 million kilometres of the Sun, the closest any spacecraft has ever been. It also set the record as the fastest human-made object, moving at 466,000 kilometres per hour. And this isn't even its final orbit. Parker will get even closer and even faster. Even at that distance, Parker's instruments revealed new insights. It found strange switchbacks in the Sun's magnetic field, which may explain how solar winds accelerate to such high speeds. It also discovered evidence of a dust-free zone around the Sun, where radiation vaporizes cosmic dust particles, leaving behind an emptier region of space. Meanwhile, Solar Orbiter has returned the closest images ever taken of the Sun's surface. Among its discoveries are small flashes, nicknamed campfires, tiny but frequent explosions linked to magnetic disturbances. These campfires may help explain why the corona is so hot, and with its instruments, Solar Orbiter is giving scientists new data on the particles streaming from the Sun across its orbit, improving our understanding of space weather. These are just the first chapters of what promises to be a long and fruitful story. As both spacecraft continue their journeys, each orbit brings them closer to solving the mysteries of our star. So, what does all of this mean for us every time Parker dives closer and Solar Orbiter takes another image? We learn more about the forces that shape not just the Sun, but our daily lives here on Earth. The light and warmth we depend on are only part of the story. The Sun is also a restless, unpredictable giant, and our technology-driven world is more vulnerable to its storms than ever before. By studying the corona, by understanding solar winds and CMEs, we're not just satisfying curiosity. We're preparing for the day when a massive solar storm does head our way. It's not a question of if, it's a question of when. And thanks to missions like Parker and Solar Orbiter, we may one day have the ability to predict, prepare and protect ourselves. The Sun is our star. It gives us life and it can take it away. But by daring to reach for it, we are learning how to live safely under its fire. As Parker Solar Probe and Solar Orbiter continue their missions, the discoveries will only grow. We will witness the Sun in ways no humans have ever done before. And with each new insight, we take one step closer to understanding the cosmic engine at the heart of our solar system. If space inspires you the way it inspires us, consider subscribing to Cosmic Compass for more stories about the wonders of the universe. Together, let's keep exploring, learning, and reaching further. After all, the more we understand the cosmos, the better we understand ourselves. Thank you for joining us on this journey, and until next time, keep looking up.